We're asked to sketch the curve y equals x squared 3 minus x in this question. Now, if we were to expand this out, we'd get 3x squared minus x cubed. And the leading term, the one with the highest power, is this x cubed, but it's minus x cubed. This is a cubic equation, cubic function, I should say, and they look like this or like this. So let's bear that in mind. Now, the y-intercept is when x is 0, we're just going to get 0. And then the x-intercepts, that is when y is equal to 0. So it's either going to be when this bracket is 0, which gives me 3, or when this x squared is 0, which gives me 0. Now, importantly, this is a double root because of the squared factor. And what it's going to mean later on is, for example, if I was to sketch y equals x minus 2 squared, I'd get a double root at 2, and the quadratic would come down, just touch at the axis, and then go back up. That's going to happen here. We're not going to get 3 intersections, we're just going to get, well, we're going to get 2 intersections, but one of them is a double root. And that is enough to be able to do this sketch. There we go. I know it's going to go through 0. I know it's going to go through 3. I'll just add that in a minute. Let's have it coming down. Just touches, goes back up, and then back down. And I'll put that in as 3. So that is our cubic function. And we've stated the coordinates of points of intersection. Maybe I should just put 0 there. Yeah, technically, okay, let's write in 3, 0, and 0, 0, just to make it extra clear. Next up, we're told that the curve y equals x squared 3 minus x, is one we're dealing with, is translated by 2 units in the positive direction parallel to the x-axis. That means it's going to move to the right, essentially. It's just you don't say to the right because you could orientate the axes in a different way. It would still be parallel to the x-axis. States the equation after it's been translated. So f of x transforms to f of x, and remember it was 2 units in the positive direction. That means we put it inside the function because it's x direction, and it's going to be minus 2. Now let's just take a little look at why that is. Because if you had some x values, let's say 5, 6, 7, then your original function would be f of 5, f of 6, f of 7. Our f of x minus 2 function is then going to be f of 3, f of 4, f of 5. And if we were to plot that, okay, just a little sketch of what's going on. So maybe the original function 3, 4, 5, 6. Maybe it looks like this. Okay, that's my original function in purple. But now I see, well, at 5 now, it's going to be f of 3. And at 6 now, it's f of 4. So you can see basically this point has moved to here. This point has moved to here. Hence, you can now see illustratively, is that a word, graphically, that it has moved to the right, or essentially 2 units in the positive x direction. So back to the question, we've got y equals x squared 3 minus x. This becomes y equals, and then we just replace all our x's by x minus 2. 3 minus x minus 2. And that's going to give me 3 minus x. I'm going to get a plus 2, so it's actually going to be 5 minus x here. Okay, nicely done. Very last bit. determine fully a transformation that transforms the curve, the original curve we had, to y equals a half x squared 3 minus x. Now, if we have our function f of x, it is now going to the same thing but a half. It's outside the bracket. Essentially, we're finding our function and then we're just timesing it by a half or dividing it by 2 equivalently. And all our points are just going to drop. If they were, say, here, then they're going to be half as much. So this will go down here, this will go to here. Yeah, it's quite hard to show, but like that. And this is a stretch by scale factor a half parallel to the y-axis. Parallel to the y-axis means it's like it's in this direction. You can also, you do get away with saying in the y direction, and actually, to be honest, that's often what I write, but it's always like in the mark scheme, it's always like written to the side saying accept this. So technically, this is preferred.